Welcome to the Explainer. Today, we're looking at some really fantastic notes on Haskell programming put together by a developer named Aang. We're going to be exploring a super sleek refactoring technique that takes your clunky, repetitive code and transforms it into something beautifully concise. So if you write in Haskell, or, really any functional language, you're absolutely going to love how this cleans up your workflow.
Okay, let's dive into this. Aang starts us off with a really fantastic point about perspective, and it perfectly highlights a classic tension in software design. Look, if you're coming from Golang, you're probably incredibly used to explicit error handling. You're probably typing if error not equal nil in your sleep, right? You check the error, you return the error, and you move on. Haskell, though, offers a much more concise functional style. So what looks like elegant efficiency to a Haskell developer might actually look a little cryptic or implicit at first glance to a Go developer.
Which brings us to Section 1, the boilerplate problem. Let's talk about dealing with manual pattern matching.
When you're dealing with operations that might fail, you frequently end up writing all this repetitive code just to route your error states. Traditionally, using a case result of pattern match forces you to manually type out both the success and the error cases. This results in a highly redundant left error branch whose literally only job is just to pass the error along. And this brilliantly illustrates the shift. Aang's proposed refactoring uses traverse and an anonymous function handling the bytes, and it fundamentally changes the game here. We are literally erasing lines of boilerplate code and getting straight down to the business logic. Moving right along to Section 2, the traverse solution, where we actually eliminate that boilerplate.
Let's break down this definition, because understanding traverse is absolutely central to the magic here. It's smart enough to understand the context of your data's success or failure. I want you to think of left as a stop sign or an error state, and right as a green light or a success state containing your actual data, which in this case is our bytes. Traverse basically just looks at your result. If it sees a left error, it immediately short circuits. Boom, done. But if it sees a right bytes, it actively runs your provided function on those bytes. You don't have to manually tell it to do this routing, it just inherently does the whole shebang for you.
Now, what's really interesting about this slide is the exact logical flow of what happens under the hood when traverse f result is called. It's elegantly simple. Step 1, it checks the result. Step 2, if it's a left, it short circuits and simply returns pure left error, without ever even touching your function f. This saves you computation time and totally cleans up your code. Step 3, if the result is right, it executes your function f on those bytes. It's totally automating that clunky case statement we saw earlier.
Let's head into Section 3, refining with named functions. Because we aren't stopping at just a basic fix. We're going to take this solution one step further to show off some functional programming best practices. Let's move to and see how this builds on our previous step. You see, while an inline anonymous function certainly works, it can be kind of clunky to read right smack in the middle of your main logic flow. By transforming this into a named function, traverse, write output, outpath, result, the intent of the code suddenly reads almost like plain English. So the crucial point is how this new explicit write output function operates behind the scenes. Write output takes the outpath and the bytes. Inside that named function, it creates the directory if it's missing, it writes the file using the bytes, and finally it returns pure outpath. By pulling all these file system operations out into their own dedicated space, our function f in the traverse call is simply and elegantly represented as just write output outpath. It cleanly encapsulates all those messy I/O details completely away from your main control flow.
Which brings us right back to our initial Golang comparison. Does this refactoring reduce readability, or does it just redefine it? If you're used to seeing every single error explicitly handled line by line, hiding that logic inside traverse might feel like magic, or, maybe even a loss of control. But once you actually understand the pattern, it completely removes the visual noise and lets the true intent of your program shine right through. It challenges us to think about what true code elegance really means for our own projects. So, what do you think? Thanks for joining me on this explainer, and keep exploring these fascinating patterns.